Hello, and welcome to today's session on Azure Container Apps and how they can help us as data engineers. So, my name is Ben Jarvis. I'm Head of Technical Excellence at Adatis, who are a Microsoft Gold partner focused on data and AI. So, I've worked across a variety of areas of IT for the past 10 years, ranging from .NET development through to infrastructure and DevOps, and now my main focus, which is data platforms. So over the past 4 years, I've been working with Adatis, where I've architected and delivered a variety of solutions across the full Azure stack. So in today's session, I'll start by giving an overview of what Azure Container Apps is, and then we can begin to look at how it's different to some of the other Azure services out there that are quite similar. We'll then understand how it's useful to us as data engineers and some of the sort of key use cases for it. And then before we dive into the demo session, I'll do a quick explanation of some of the key concepts. So we'll start with an explanation of what containers are. So they're obviously the sort of basis for the service. And then we'll look at a couple of the other supporting services that enable Azure Container Apps to do what it does, which are Kubernetes and Dapper. Then once we've nailed down those basics, we'll dive into the demo. And during that, I'll show you how to develop and deploy some different types of container apps. So what is Azure Container Apps? So Azure Container Apps was one of the key announcements at Microsoft Ignite towards the tail end of last year. So it's pitched as a fully managed serverless container service that allows us to run containerized applications in Azure. So we can write code in virtually any modern programming language and use in virtually any framework. And basically, as long as that code can be packaged up into a container, we can deploy it to the service. So the service can scale dynamically based on the load that's put towards it. So say you're using it as an API, it will scale out the number of machines running your container based on how many requests are being put to the service. And therefore, it hides some of that complexity of managing that scaling that you have to sort of consider with other services. It's based on some of the Microsoft open source tools that have been released recently. So the key one is Dapper. And that means that it can host a variety of different applications. So it can host anything from HTTP APIs to event-driven applications that are processing messages from a queue, all the way through to batch-based applications where you're wanting an easy way to just run a bit of code somehow. So the service is currently in public preview. And it is a bit rough around the edges still. And as yet, there's no timelines for when it's going into general availability. So one of the key features that I mentioned of the service was that it's serverless. So what does that mean? So as a quick disclaimer, it doesn't mean that it doesn't run on a server. So when we say something is serverless, it's different to conventional cloud applications, because you're only paying for what you use rather than paying for a service to be online constantly. So in terms of Azure Container Apps, the cost for the service is made up of 3 key parts. So the first one is the number of requests. So you're paying per request to your application. The next one is CPU usage. So you're paying for the time that application is using a processor for, and the number of cores that it's using within the processor. And then finally, you're paying for the amount of memory that your application is using during the time that it's running. So the one problem with this pricing model is it's very difficult to calculate an estimate of how much it's going to cost. So yeah, in terms of my experience, I've worked with similar services like Azure Data Factory, which has a similar pricing model, and Azure Functions, which again is very similar. And in the time I've been working with them, it's been very difficult to actually get an accurate estimate of how much a workload is going to cost when it's running on that service. But from experience, if your workload is something that has bursty usage, so it's not being hammered constantly, then generally serverless options work out well, and they will cost you much less than a conventional service in Azure. So in terms of Azure Container Apps and how it gets deployed in Azure, there's two key components. So the first is the Container Apps environment, and that basically acts as the boundary for our application. So say we were deploying a set of microservices that make up a full-blown sort of application. We might have some services that we want to be able to communicate externally, so people could call them from say, a web app. And then we might have some services where we only want them to be able to communicate with each other. So by having the Container Apps environment, we can control that, and we can basically control what Container Apps can communicate with each other and what apps can communicate with the outside world. So within that Container Apps environment, we've got the actual container app itself. And they're our individual applications that we're deploying. So like in this example here, we could build those as a Python app and package that up as a container and deploy it to the service. Or we could deploy it as Node or C# or essentially whichever language we want. We'll see in the demo how these look in the Azure portal. But yeah, the key thing to remember is there's two separate resources. There's the Container Apps environment, and there's the actual container app itself. So how is it different to other Azure resources? So there's a few services that are very similar to container apps. So the two that fit in the serverless space are Azure Functions and Azure Container Instances. And then in the conventional PaaS space, where we're paying a fixed sort of monthly cost for a set of virtual machines, are Azure App Service and Azure Kubernetes Service. And they can also be used to host applications that sit within containers. So just taking the serverless offerings on their own, we can look at how container apps is different to functions and container instances. So this table shows some of the key similarities and differences. So the main thing that sets container apps apart from the other options is its flexibility it gives us in terms of being able to use any language or SDK. And also the level of complexity involved in managing it. So if we compare it to something like container instances, that gives us the same level of flexibility, so it's pretty similar. But it's in terms of container apps, it's much easier to actually deploy the application and also orchestrate the running of it. Whereas with container instances, a lot of work goes into sort of scripting out the creation of them and being able to spin them up when they're required. And then compared to Azure Functions, container apps gives us much more flexibility. So with functions, we're sort of constrained by the Microsoft-provided SDKs. And it removes some of the limitations around execution time, which would have previously prevented us from running things like batch jobs in a serverless environment. So to summarize that, we can agree that Azure Container Apps are slightly more difficult to develop and manage when compared to functions, but they're much easier to manage than Azure Container Instances. But then when we compare them to functions, they give us much more flexibility because we're not constrained by those Microsoft-provided SDKs. And that also means that our application is much more portable. So we could quite easily create an application, run it on Azure, run it on GCP, AWS, or even on-prem, as long as that environment supports the running of containers. In terms of when we'd use each service, my recommendation would be for very simple use cases or applications that are truly event-based. So you're processing, say, a queue of messages and you want to do something with those messages, then I'd probably go with Azure Functions. But when you're deploying batch applications, HTTP services, or more complex applications where you need that flexibility, then I'd probably go with container apps. Then once container apps is in GA, then the use cases for container instances are really limited. And so I'd probably steer clear of that service for any new development because I think container apps is really sort of the way forward. So now we understand what the service is. How is it useful to us as data engineers? So there's three real use cases where we can use it as data engineers. So the first is running batch jobs. So that's where we need to run some code periodically. We can package that code up, say it's a console app, as a container, and then we can run it as a container app. The next is ingestion. So say we're calling an API every few minutes to grab some data, and we want to land that in our platform. We can easily, again, package that up as a container and run it on container apps and get all the benefits of it being a serverless environment. And then finally, on the ingestion point, previously, if we had a service within that we're trying to ingest some data from that wasn't supported by Data Factory, then we might spin up a job in something like Azure Batch with some code to ingest the data from that service and drop it down somewhere. But now we've got container apps, we can potentially deploy that same code as a container app and then have only pay for the time that process is running. And then the final use case is integration. So that's where we either want to expose an API with some data from our platform, or where we want to push some data to another application from our platform. So before we dive into the demo, I just want to sort of nail down some of the key concepts. So the first one is containers. So what are they? So this is the definition of containers from IBM. So essentially, it's about packaging up pieces of software so that they can be run anywhere. So to understand that concept, we need to go back to the days not that long ago, where we had applications running on physical servers. So back in those days, as developers, we would write some code, and then we'd need somewhere to deploy it. So we'd probably go out and buy a physical server. And then on that server, we'd install an operating system. So it might be Windows or it might be Linux. We'd then deploy our application onto that server. And generally, it would be the only application that's running on the server, because there might be issues with incompatibilities between applications, or applications having different dependencies or different performance requirements. So if we wanted to scale this out and run multiple instances of our application, or run multiple different applications, then we'd probably need to go out and buy multiple physical servers, each with their own instance of the application being installed. So as things moved on, servers became a bit beefier, and something called virtualization came along. So this meant that we could have one physical server, but on that server, we could install multiple virtual servers. So each of those would have their own operating system, but the operating system would be isolated from the hardware, and we'd be able to have multiple instances of that server running on the same physical machine. So each of these virtual machines appears as a separate server to anyone that's interacting with it, but they all sit on a single physical server, which we call a hypervisor. So this has been one of the key things that's allowed things like the cloud to take off, because rather than having to have lots of physical servers that run each workload, we can now group them together as virtual machines and run multiple applications on a single physical machine. So that means we don't need as much data center space to run lots of applications, but it also saves costs, because we're obviously not paying for those physical servers, and we're probably making more use of their computing power as well. For some applications, this model obviously doesn't work, because they might have specific performance requirements, so there still is that need for physical servers. But in the most part, it works really well, and services such as Azure use this approach as their foundation. So the next evolution of virtualization was containerization, which is effectively another form of virtualization, but rather than virtualizing the server, we're virtualizing the application. So in this model, we still have a server, which may well be a virtual machine, and all of our developers are still writing their code. But rather than building that code and then publishing it directly to the server, the developers will package that code up into a container. And that container will contain all of the dependencies required by the application. So that's things like frameworks, things like SDKs, and all of the stuff that we'd usually have to install on the server to run that application. So then we take that container and we publish it to what's called a container registry. And this is essentially a repository of all of our different containers and different applications that we want to deploy. So then we can deploy that application to our server as a container. So this means that our application and all of its dependencies are completely isolated from everything else that's running on the server. So that means we can host multiple applications on that one server. And because they're completely isolated, there's no risk of any interaction between them or any issues with them requiring different bits of software that will conflict on the server. So this opens up a whole world of possibilities because we can essentially package up our application and run it anywhere. So as long as that server can run containers, then we can deploy our application and run it without having to worry too much about the configuration of the actual server that we're running on. So then this means we can further reduce our number of physical servers and our number of virtual servers, because we can obviously deploy those multiple applications onto a single server. And that's one of the things that's enabling Microsoft to take this serverless approach while still giving us the flexibility. Because rather than having to spin up a VM every time we want to run a request, they can have a pool of VMs that are ready to go. And then as soon as we make a request to our application, they will run the container on that server, and then our application will work. So another two key technologies that make up container apps are Kubernetes and Dapr. So I'm not going to go into too much detail on these because they're massive subjects on their own, but I'll give a quick overview. So Kubernetes is what we call a container orchestrator, which means it's responsible for managing containers in a variety of ways. So Kubernetes is a Greek word, which has the meaning pilot or helmsman, hence the logo. So therefore, it's essentially responsible for running our containers and ensuring that they're available, fault tolerant, and can communicate with each other and also the outside world. So it's quite a big and complex topic, but when running containers at large scale, something like Kubernetes is required to orchestrate everything and make sure that our application is scalable and highly available. So Azure Container Apps abstracts away all of the management of Kubernetes for us, and it means that we can publish our application up to the service and not have to worry about making sure Kubernetes is configured properly, or having that headache of needing to know the ins and outs of Kubernetes and how to troubleshoot or configure it. The next service is Dapr, and again, this is quite a big and complex topic, so I won't go into too much detail. But essentially, Dapr is a layer that sits on top of Kubernetes and makes it easier to develop microservices-based applications that are hosted on the Kubernetes platform. So the whole idea of Dapr is it gives us a set of building blocks that we can use to build our applications. So these include things like secret management, state management, monitoring and logging, and event-based triggering, as well as managing communication between different services. So the way Dapr works is quite clever in that it's independent of the language being used, so we're not tied to a specific language. And that's because it runs in what we call a sidecar pattern, where it runs alongside the application that we're deploying rather than being part of it. So we're not going to be using it explicitly in our demo today, but it's one of the key technologies that gives container apps the sort of features that it has to offer. So now we'll dive into our demo. I do have to apologize because the service is still in preview and it's a bit flaky at the moment. So I'm praying to the demo gods that the demo is going to work, but fingers crossed it will all be okay. So today we're going to demo a very simple application that will demonstrate some real-time data ingestion to land data into a SQL database, and then push that data in a summarized form off to a web application. So we're going to be using a container app to ping an API every 10 seconds that will give us some data on temperature and humidity readings that are coming from various sensors. So we're then going to land that data from the API into an Azure SQL database so that we can query it. And then once the data has been is in that SQL database, we're going to have a HTTP API that sits on top of that and does some summarization of the data so it can be passed off to the web application. And while it's doing that, it will also apply some other logic to generate alerts when say, the temperature goes outside of a range of values. The API will then be called by a very basic web app that serves up the data. So we'll now move on to the code. So let me share my screen on here. So if we start with Visual Studio, just to show the API that we're sourcing the data from. So this is quite a simple bit of .NET code that I've created. So it's an ASP.NET Web API project. And within this project, we have one controller, and that controller has one endpoint, which has this get method on. And all this will do is generate a set of random values for 10 dummy sensors. So it will pass off the sensor ID as our unique identifier. It will also output the temperature, which is just a random number between 15 and 30. And then it will also output a humidity value, which is just a random value between 70 and 100. So we've got this web application deployed up to Azure. And that is deployed as an Azure app service, which you can see here. So that's got our .NET application on that we're sourcing the data from. And then if we test that API, I'll just run this query. Wait for that to run. So we can see the data that's coming back from the sensors. So we've got our sensor ID, then we've got our temperature and humidity values. So we obviously want to ingest that data from the API. So we've got a very simple .NET console app, which will ingest the data. So if I go to my console app, so this application just sits in a loop. And it will basically ingest, so it will run the query against the API to pull back our data. Then it will create a connection to SQL. And then for each sensor, it will run a stored procedure to add the data to the SQL database. And then it will wait 10 seconds and then ingest that data again. And each time it's running, it's executing a stored procedure. And this stored procedure will add the sensor to a table if it doesn't exist, and it will add the sensor reading to a table as well. So it's pretty simple code. So to deploy this .NET console app up to container apps, we need to do two things. So we need to generate a container, and then we need to publish that container up to a container registry so it's accessible by the service. So within Visual Studio, it's very simple to add support for containers on a .NET application. So all we do is right-click on the project and add Docker support. And once you do that, Visual Studio will automatically generate all of the bits that you need to generate that container whenever you build your application. And the key part to this is the Docker file. And this is basically the set of instructions that we define that tells the software how to generate our container. So it starts by using a reference image, which in this case is a Microsoft-provided .NET 6 image. And then we also use the .NET 6 SDK image, which is what we need to be able to build our software. So then it will run the standard steps of a .NET build. So it will restore any NuGet packages we have, and then it will run the actual build, and then it will run a publish to publish our code and generate the artifact that we want to deploy to our container. And then finally, it copies that output from the build over to our runtime image, which is what we're actually going to be running in the software. And with this application, it's just a console app, so there's no endpoints that need to be exposed, so we don't need to expose any HTTP APIs or anything like that. It's just a console app. So now within Visual Studio, whenever I build my application, it will generate the container for me. And the same goes when I debug the application. So say I want to run this. What it will do in Visual Studio is it will execute all of the Docker commands to spin my container up locally. I've got Docker for desktop installed on this machine. And then when I debug my application, it will actually be running within the container. So I've set a breakpoint here, and this should stop once the application kicks off. So yeah, it's just like debugging a normal .NET app, but the main difference is your code is running within that container. So now we've got the bits in place to generate the container from our application. We now need to publish this up to Azure Container Registry, which is going to be our container registry that we're using. So to do that, we just right-click and then publish our app. Obviously, doing right-click and publish is the sort of cardinal sin. So normally we'd be doing this through a CI/CD pipeline, but I just want to show you how simple it is to do this. So then we've got a publish profile already in place here, but if we want to create a new one, we would just select new, and then we select Docker Container Registry, and then we can select Azure Container Registry as our target. And then we can select the details of the container registry we want to use. And then once we hit finish, that would generate all of the necessary bits to be able to publish that container up to Azure. So I've already published this one, and it does take a while the first time you do it. So yeah, I'm not going to demo that piece in this session. So now, if we hop over to Azure, within Azure, we can see our Azure Container Registry instance, and that's obviously where we're publishing our container to. So if we jump into that and look under repositories, we'll be able to see our ingest API data image, which is our container that we've published from Visual Studio. And if we look at the latest version, we can see the relevant commands in Docker for us to be able to actually pull that image and use it somewhere. So now we've got our image. So we've built our application, and we've generated our container that's got all of the dependencies needed to run the app. And then we've published that up to Container Registry. So now we want to actually create our container app. So what I would do is copy the name here and go to Create. So I do have the script required to actually deploy the container app using the Azure CLI. And if I move this script over, so this has the relevant pieces to create our container environment and then create our container app. But there's some issues at the moment with the Azure CLI integration that mean that it's not working. So as of yet, the only way I've found to create the container apps is to do it through the portal. So we've already created our container app environment. So this is here. And if we look at that resource in Azure, it's very simple. So there's not really much to it. But if we create the actual container app, so search for the resource. And go to create. So we need to select the resource group that we want it to be deployed to. So if I select my container apps demo resource group, then if I give it a name, So I'll just replace that with O2. And then we select our Container Apps environment. So here I've already selected the existing environment that I've created. So then if we go to the app settings, by default, it will spin your app up with a quick start image. But we obviously want to use our custom image that we've already generated. So we can select Azure Container Registry as the image source. Then we can select our instance of Azure Container Registry. And now if I select my image and select the tag as the latest, there's a couple of other settings at the bottom here, which are whether we want to enable ingress for applications that need a HTTP endpoint. Because this is a console app, we obviously don't need to expose it to the outside world, so we'll leave that as disabled. So then if we click on Review and Create, I'll just give it a name. And hit Review and Create. And now create that instance. So now that will go off and do the necessary work in the background to deploy our container app and spin it up in the Kubernetes instance that's sitting on the Microsoft side. This shouldn't take too long to create, so we'll just leave that running. But just in Azure Data Studio, I've already cleared down the table that contains my data. And it looks like the application is actually, yeah, it's already up and running. So we can see new data coming in. And we can see we've got our different sensor IDs. We've got our date that the reading was taken, and then we've got our temperature and humidity values. And then if we hop over to the Azure portal, we'll be able to see that our container app has been deployed. So you can see various stats about the app. So you can see CPU, memory usage, as well as network usage. We can also configure the ingress settings from here. So if we wanted to enable that HTTP ingress, we could. And then we've also got the ability to set up CI/CD. So we can set that up with Azure DevOps or GitHub Actions. The other area we can look at is revision management. So there's one setting I need to tweak here, which is the scaling settings. And we just want to set that so the service keeps the app alive and makes sure there's always one instance of it available. So I'll just hop over to here and create that. So we'll let that deploy in the background, but while that's running, we can take a look at our second app. I'll just check where we are for time. Yeah, we've got plenty. So now if we hop back to Visual Studio, we can take a look at our API that we've created. So again, this has been set up as just a bog standard ASP.NET Core web API. So there's no specific configuration we need to do to the actual app to get it running in Container Apps. But this application just has one API controller, again with one method. So this method is outputting a sensor summary. So the code here is pretty simple. So what it does is it opens up a connection to SQL. Then it will execute a store procedure to get a summary of the data. And then it does some work to get that data into a specific JSON format that we can use from our web app. And while it's doing that, it's also applying some logic to check whether the temperature levels are outside of the boundaries we've set. So here I've set if the temperature is above 27 degrees, then we want to raise an alert to tell somebody that temperature has been above that level. And then the same if the temperature is outside of the range of 23 to 25 degrees. We also want to flag that as an alert on the app. So the process for deploying this app is similar to before. So to generate the Docker file, again, we will just do right-click on the project, then add Docker support. And then that will generate our Docker file for us to build our container. And in this one, the settings are slightly different. So Visual Studio is able to adapt to the type of application you want to package. So it knows if it's a web app, and it knows if it's a console app. But in this case, instead of using the .NET 6 image, we're using the ASP.NET 6 image. So it's made that switch for us. And we've also got a couple of extra statements on line 5 and 6, which are basically making sure our container exposes port 80 and port 443 so that we can interact with it as a web app. And then the steps are pretty much the same as before. So we're doing that .NET restore, we're doing the .NET build, and then we're publishing. And then we're copying the outputs over to our final ASP.NET runtime image. So that's all set up. And if we build or run our application, so say I want to run it locally, that will spin it up again in Docker, and it will run all of the Docker commands to get that application running. And then, like before, I can debug it locally, but this is running in the Linux container environment that's on my local machine. So it makes debugging really easy because you're debugging in the same environment as the application's running, essentially. So if I go to API/. So we can see the output of our API here. And that's running on my local machine. So again, a similar process to before. We would publish that container and push that up to the container registry. And if we hop back over to the Azure portal, we're able to see that instance in the container registry. So under repositories, if we have a look at integration API and then tags latest, we can then see the command to do a Docker pull and pull that image down to a server where we want to run it. So now we need to create the container app for our API instance. So to do that, it's a similar process to before. So I'll copy this name. And then I will create a container app. So I'll change my resource group. Switch that to O2. And then we've already selected our container environment. So now, again, I untick that we don't want to use the quick start image. We're using the container registry. We select our image, select our tag, and give it a name. So then, in this case, we want to enable HTTP ingress. So we enable that, and then we allow traffic from anywhere. So because we're wanting to access this from a web API, sorry, a web app, we want to allow traffic from anywhere. And our target port will be port 80. So that's the port that we've exposed from our container. So now if we hit review and create, that will then create our container app. So while that's running, if we have a quick look at the logging, so if we pop into log analytics, we can go to logs, and we can view the logs for our console app. So I've got a quick query here, and this just is written in the custo language, so this is just log analytics that we're querying. And you can see we've got a collection for our container apps logs, and then we're searching for our specific instance of the container app, and we want to sort those messages by the time they were generated, descending, so we get the latest messages. So if we now run that query, we can see that the app is running. So you can see our latest entry was 2 o'clock. So that's right now. And you can see the output from the console. So anything I output to the console from my .NET app will be pushed off to Log Analytics automatically, so I can query it. So that makes it quite easy to debug these console-type applications while they're running in the service. So now that's done, our deployment is finished off in the background. So if I go to our resource, we can then click on this URL, and this will take us to our application. So if I hit the API endpoint, actually I've got a pre-created query to do that. So I'll just replace this URL and run that request. Then that will give me back my summarized data. So you can see for each sensor, we have the date that we've summarized the data to. So we're summarizing it to the minute level. And then we can also see any alerts that have been generated as well. So the API is now working, and that's running as a container app. So we're only paying for each request that's made to the app. So now we've got both of our components deployed to Azure. So we've got our console app that's ingesting from the API, and then we've got our actual API that we're going to use to integrate with our app. So now if we hop over to our app, so if I run this, we should start to see some data coming through. So this is just a very simple JavaScript app, and all it's doing is pinging our API endpoint and collecting data from it. So you can see here that it's pulled through the data from the API, so that's all summarized to each minute. And then we can also see the alerts coming through. And what we should see is as this process runs, we should see the graph moving, and we should see everything coming through in real time. So yeah, that just shows how easy it is to get something deployed, well, get something packaged up as a container and then deployed to the service. And there really are no changes that you need to make to your application. It's all sort of out-of-the-box functionality in Visual Studio. And yeah, essentially, as long as your application can be published as a container, we can run it in this service. So that's all for the demo. What I'll do is switch back to the slides. Yep. So yeah, just to wrap up. So we've learned about Azure Container Apps and what it is. So we know it's a new offering in Azure that allows us to run our applications in containers, but in a serverless manner. So we've also learned some of the key use cases where it might be useful to us as data engineers. And then we've done the demo to show how easy it is to deploy those applications up to the service. So that's all for today's session. I've included a link to my GitHub, which is where I'll publish the demo code after this session. There's also a QR code and link for the feedback. And I've also included my LinkedIn and my email if you'd like to get in contact after. I'll be over on the Adatis stand after the session, so if anybody's got any specific questions, then feel free to come over. And we've also got a game on the stand, which is quite cool and has some cool prizes to be won. So yeah, that's all for today's session. Does anybody have any questions? Yep, at the back. Yeah, so so it's serverless, but you're also able to keep an instance available. So if I hop back to the Azure portal and look at some of the scaling settings. So if I create a new revision of the app and go to scale, what we can do is keep instances available constantly. So say we've got an API, and we don't want there to be any delay in making requests to that API. We can make sure that there's always one instance available. And the way the pricing works is you're not charged for the So you're charged for the time the application is idle, but it's a much lower cost than it would be if it was in use. So say you've got an API, it makes sense to keep that one instance available so you don't get that sort of time required for the service to deploy your app before it's available. Yep, and so it will automatically scale for you. So yeah, if you're throwing HTTP requests at it, it will look at the number of requests you're firing at the service, and then it will automatically spin up new instances as required. So the scaling is quite flexible. Great, so I think that's all. I'll leave the slides up in case anybody wants to catch those. But thanks for coming.